All right, hello again. So we're going to do the last final on titrations. Okay, so this is to be done independently, strictly by you, without any outside help from the internet or any source of anything from a person or online. Okay, and there's an authenticity statement at the end of the evaluation sheet that you need to sign off on, and will honor your and trust that you have withheld up to those standards for this lab. Okay, so that way I can still include this component as the 10% skill for the grading. Okay, all right, so for today, you're going to determine the percent of tartaric acid in white wine. This is the sample of white wine that I have taken all the samples from to measure. Okay. And white wine, all different types of wine have a variety of different components of the chemicals in them to give them their flavor and taste. Particularly the acidity component is extremely important. There's a couple different types of acids in white wine or in any wine, and two of them being the most highest components are tartaric acid and malic acid, and tartaric acid being the larger of those two. So we're going to assume that all of the acid that we're measuring in our sample is coming from tartaric acid, even though it really isn't. There's other acids in the wine as well. Okay, so we're just going to assume that it's all tartaric acid. Okay. All right, so just a little introduction to the lab and very briefly guidance on the calculation, because this is the final, and you hopefully you have had enough practice at this point and you're very comfortable and know what to do. Okay? All right, so the purpose of the lab, we're going to determine the percent of tartaric acid in a sample of white wine using titration. Okay, so the first step we want to do in any titration is to write the chemical reaction equation that's going on between the acid and the base. Okay? All right, so I've already given that to you, so you don't need to look that up. Right? It's 1 mole of tartaric acid is 2 moles of sodium hydroxide, giving us 2 moles of water and 2 moles of this salt right here. Okay? All right, so our typical setup that we are used to and will be using is a burette that's going to be filled with a sodium hydroxide solution. We're going to be filling this solution with the standardized sodium hydroxide solution that was used in the standardization lab that you previously did. So the concentration number that you calculated for the NaOH solution from the standardization lab, you want to use that exact number for all your calculations in this lab. Okay, it should be approximately this 0.100 number, but whatever that actual number is, that's what you're going to use for your calculations. Okay, and then we're going to have 4 flasks. We're going to have an A, B, C, D flask. The A flask is going to be the Scout, and then the B, C, and D flasks are going to be the 3 trials. And each of them, I measured out 10.00 milliliters of white wine. And that was measured with a volumetric pipette for accuracy. And then I added 40.0 milliliters of our distilled water, or deionized water actually, with a graduated cylinder. And then I added 3 drops of phenolphthalein indicator. Okay, so I have all my flasks ready to go. I'm going to add my sodium hydroxide, right, to get to the equivalence point, but I will know when to stop when I see the color change at the end point, right? But we're going to be doing that drop by drop method when we know we're getting close, so we can actually catch that volume that we're going to say is the equivalence point. We don't really want to use the endpoint volume if we can catch the drop right before it that changes color. We can get the equivalence point. Okay, so you're going to measure that volume, or I'm going to measure it, and you're going to record it. You're going to use that volume for your calculation. Okay, so converting from milliliters of NaOH, and you also know the molarity of it, and you're going to convert that to a different substance. We're converting it to concentration of tartaric acid in grams of tartaric acid per milliliters of white wine. Okay, so there will be some calculations in here. Okay, and you're going to then multiply that by 100%, because that's a mass per volume percent, and that's our units that we're going to be representing for the mass percent is mass to volume instead of mass to mass or volume to volume. Okay, so that's all the information you need there. You will need a couple other things here. okay? And you're gonna do that for your B, C, and D flasks. So you do this calculation 3 times for B, C, and D flasks, and then you are going to average those numbers to get an average of the tartaric acid in the white wine, okay? So just a couple things I want to point out on the evaluation sheet. Everybody will turn the evaluation sheet in, right? And you'll fill this out up here, okay? And we're gonna scratch this section here because you can't do it. This first box up here, this is gonna be your calculation for your percent of tartaric acid, okay? And then here are your individual percents of tartaric acid, your reporting, and your average concentration of that. Down here, we're just gonna scratch this whole box. So I think this was meant to do molarity up here and percent down here, but we're just gonna, the calculation is pretty straightforward. I think we just do percent all in one step, okay? And then report it here, even though it's the same number right there. And down here is your authenticity statement that you're gonna sign off on as well, okay? So as you watch the lab video, you will also be able to record the in-lab information if you need to do the in-lab requirement. And you also will turn in and upload to Canvas in the results discussion or conclusion assignment section to include your results discussion sheet for this lab if need be, okay? All right, so now I'm gonna video doing the experiment. Okay, so here's the setup. We have our sodium hydroxide up here. I have my A flask down here that's gonna be as my scout, and I'm gonna open it full throttle and see when I get the color change, okay? I'm starting at 0.00 at the top of the burette. Stop. Okay, so I think I overshot it a little bit there because I was fooling around with the camera some, and we are slightly over 7. So let me zoom in on the burette so you can record that number for the scout. Okay. All right. So now we're gonna run our or get our B flask set up and ready to go. Okay, we're starting at 0.00. This is our B flask, our first trial for the white wine, and we were just a little over 7 mils on the scout. So I'm gonna just do a pretty slow drip here throughout. Okay, so I'm gonna point it up here so we can start doing the drop by drop analysis. Let's see, there we go. And I'm gonna rinse the flask with water and then get started again. Okay, so add 1 drop. I think we're a little ways away yet. 2 drops in there. Okay, so let's go ahead and record. Pink is really sticking around. still have some pink floating around in there. Okay, maybe we got one more drop. Okay, that is the end point. It definitely went to a different color, much more pink compared to, you can see the difference there. Okay, so the previous volume you recorded is what will be your equivalence point. Class C, we're starting at 0.00. And I'm gonna just put this on a nice slow steady drip. Go ahead and stop it for a minute, and I'm going to wash down the sides. Start recording drop by drop. Okay, I think that might have been it. So I put it next to this one, and there definitely is a color change. I don't know if you can tell, but there definitely is a color change. And this is flask B to the left, and you can see that it's a little bit lighter than B. So I think we're there. Okay, this is our last trial, flask D, on the vinegar, or excuse me, the tartaric acid in white wine determination. And we're starting at 0.00 again on the burette. Whoa. Put a nice steady slow drip here. Since we're not titrating very much volume, it's important to go slow and give it some time to react so our numbers can be somewhat or hopefully accurate. So I'm going to stop it here for a minute now because I splashed a little bit, whoops, on the sides here. I can see some pink indicator on the side of the flask. Wash down. Alright, so I'm just a little past 3 mils, so I'm going to go and put it back on the slow drip. Okay, we're approaching 4.5 mils. Okay, we're almost to 5 milliliters now. Almost to 5.5. And when we get close to 6 here, I'm going to stop it and we'll do drip by drip. Okay. Do one more drop there. Okay. Okay. So let's go ahead and do a quick rinse here. Take our volume measurement here. think that was it. But it just changed. But let's go ahead and do one more drop again, just to see. Yeah, they're definitely changed there. Okay, put that back to, can you see? Yeah, so I would say that the previous volume before this last drop right here would be the equivalence point volume that I'm going to use. Okay. All right, so take a look at all of our flasks here. And our Scout, our B, C, D, and see the slight color change in them. Okay. I think C was so accurate that the color just persisted shortly, and then eventually the pink faded away a little bit. But there we have it. Okay, so now you got your volumes. You have your molarity, your sodium hydroxide. You're going to convert to grams of tartaric acid to milliliters of wine. Multiply that by 100% to give you your mass percent. Okay? Please let me know if you have any questions.